Today we are going to learn parsing methods, that top-down parsing and bottom-up parsing. So this is the grammar and this is the production rule for the grammar. इस ग्रामर में आपका वेरिएबल्स क्या क्या हैं? ई सिर्फ एक ही वेरिएबल है, दैट इज ऑल्सो स्टार्ट सिंबल, और टर्मिनल्स आपके हैं आईडी प्लस एंड मल्टीप्लिकेशन. प्लस मल्टीप्लिकेशन इज ऑपरेटर. और आपको पास ट्री फाइंड करना है इस स्ट्रिंग के लिए. ठीक है. सो टॉप डाउन पार्सिंग में क्या होगा? पार्सर स्टार्ट कंस्ट्रक्टिंग द पास ट्री फ्रॉम स्टार्ट सिंबल एंड ट्राइज टू ट्रांसफॉर्म द स्टार्ट सिंबल टू इनपुट सिंबल. तो आप स्टार्ट सिंबल से पार्सिंग स्टार्ट करेंगे और इसको गेन करेंगे. ठीक है. तो इसके लिए अगर हम देखें तो सबसे पहले हमने ई से स्टार्ट किया और इस ई को हमने ई प्लस ई. ठीक है. फ्रॉम फर्स्ट डेरिवेशन ई डिराइव्स ई प्लस ई. अब हमें ये फाइंड करना है तो अगेन ई को जो है डिराइव करना पड़ेगा ई मल्टीप्लाई बाई ई, और फिर ई कैन बी रिप्लेस्ड बाई आई डी. तो ये आपका आई डी एंड दिस इज आई डी. ठीक है. तो इसमें हमने क्या किया? पहले ई जो है ई प्लस ई को ड्राइव कर रहा था, फिर जो राइट हैंड साइड था इसको लेफ्ट टू राइट स्कैन किया, जो फर्स्ट वेरिएबल मिला उसको हमने अगेन रिप्लेस किया किसी प्रोडक्शन रूल से, और फिर स्कैन किया जो लेफ्ट साइड था उसको रिप्लेस किया टर्मिनल से, फिर अगेन नेक्स्ट वाला, फिर लास्ट. सो इस तरीके से आप जो है ये स्ट्रिंग को फाइंड की. सो टॉप डाउन पार्सिंग में आप स्टार्ट सिंबल से स्टार्ट करेंगे, फिर उसमें लेफ्ट टू राइट स्कैनिंग परफॉर्म करके आप टर्मिनल्स तक जाएंगे. ठीक है. इसमें आपने क्या किया? एक्सपेंड किया है. तो इसमें क्या परफॉर्म होता है? एक्सपेंशन. ठीक है. और जैसे एलएल ग्रामर, एलएल पार्सिंग या एलएल पार्सर, इसमें टॉप डाउन पार्सिंग में यूज होता है, जिसमें इस एल की मीनिंग है लेफ्ट टू राइट स्कैन. ठीक है. और नेक्स्ट एल की मीनिंग है लेफ्ट मोस्ट डेरिवेशन. इसमें हमने क्या किया? लेफ्ट मोस्ट डेरिवेशन परफॉर्म किया. जो सबसे लेफ्ट मोस्ट वेरिएबल था उसको हमने रिप्लेस कर दिया. जबकि बॉटम अप पार्सिंग में हम जस्ट इसका रिवर्स करते हैं. हम यहां से स्टार्ट करेंगे. ठीक है. आपको क्या गिवन है? आईडी प्लस आईडी. ठीक है. आप इस स्ट्रिंग से स्टार्ट करेंगे और ऊपर तक जाएंगे. तो इसमें भी लेफ्ट टू राइट स्कैनिंग परफॉर्म करेंगे. तो फर्स्ट आईडी कैन बी रिप्लेस बाय ई. तो ये ई से रिप्लेस हो सकता है. ठीक है. फिर अब आपके पास क्या सिंबल्स हैं? ई मल्टीप्लाई बाय आईडी प्लस आईडी. सो जब नेक्स्ट फिर स्कैनिंग करेंगे, अगर हम इसको लिख दें ई मल्टीप्लाई बाय आईडी प्लस आईडी, तो मल्टीप्लिकेशन ऑपरेटर जो है स्टार, वो कहीं किसी से ड्राइव नहीं है. ई प्लस स्टार का कॉम्बिनेशन भी कहीं राइट साइड में ड्राइव नहीं है. ई स्टार और आईडी का भी कहीं ड्राइव नहीं है. लेकिन स्टार उसके बाद आईडी जब फिर से आता है तो ये आपका किससे रिप्लेस हो सकता है? ई से. ठीक है. अब आपके पास क्या हो गया? स्ट्रिंग कंप्लीट ई स्टार प्लस आईडी. अब फिर लेफ्ट टू राइट स्कैनिंग करेंगे तो ई स्टार ई ये राइट साइड में है, इसको रिप्लेस कर देंगे लेफ्ट साइड से, तो आपको क्या मिल जाएगा, ई। ठीक है, अब आपके पास ई प्लस आई डी है, तो ई प्लस आई डी राइट साइड में कहीं नहीं है, प्लस भी नहीं है। आई डी को हम आप रिप्लेस कर सकते हो किससे, ई से, और ई प्लस ई जो है यहां राइट साइड में, इसको रिप्लेस डायरेक्ट कर सकते हैं ई से। स्टार्ट। ठीक है, तो इसको जिसमें आपका एरो कनेक्टेड नहीं है वो पार्ट आप रिमूव कर सकते हैं, तो आपका कुछ इस तरीके से ट्री जनरेट होता है। और जो रिपीटिशन पे है, जैसे ये इसको मर्ज कर सकते हैं। तो आपका ये बॉटम अप पार्सिंग है, आपने स्ट्रिंग से स्टार्ट किया और टॉप तक गए। अगर आप इसको देखें, इसमें भी स्कैनिंग लेफ्ट टू राइट हो रही है। अगर हम इसको देखें ऊपर से, तो हम ये फाइंड करेंगे कि पहले आपने ई जो है, ई प्लस ई था, आपके पास एक प्रोडक्शन रूल था, बट आपने जो राइट मोस्ट पार्ट था उसको पहले रिप्लेस किया। ठीक है, अगर हम यहां से आए तो ऐसे दिखेगा कि राइट मोस्ट पार्ट, जो राइट मोस्ट वेरिएबल था, उसको पहले हमने चेंज किया है, इसमें चेंजेस परफॉर्म किए। तो आपने क्या किया, ये जो स्ट्रिंग था इसको रिड्यूस करते गए, तो इसमें परफॉर्म क्या होता है, रिडक्शन, जबकि टॉप डाउन में क्या परफॉर्म होता था, एक्सपेंशन। और इसमें एलआर पार्सर आप यूज कर सकते हैं। एलआर पार्सर में एल जो है वो क्या है, लेफ्ट टू राइट स्कैनिंग, और आर जो है वो राइट मोस्ट डेरिवेशन इन रिवर्स ऑर्डर। ठीक है, जब हम रिवर्स में जाते हैं तो हमें लगता है कि वो राइट मोस्ट पार्ट फर्स्ट रिप्लेस हो रहा है। ठीक है, सो दिस इज टॉप डाउन एंड बॉटम अप पार्सिंग।
What does the sentence Ingrid saw the Martian with a telescope mean? Seems pretty straightforward, right? There's a Martian, it has a telescope, and Ingrid is seeing it. But wait, about half of you are saying right now, that's not at all what I thought it meant. I thought it meant that Ingrid had the telescope and she's using it to look at the Martian. Well, you're not wrong either. This sentence is ambiguous. In one meaning, the Martian has the telescope, and in the other meaning, Ingrid has it. So how is it that one sentence can have two different meanings? Well, the difference between the two meanings is who has the telescope. In other words, which part of the sentence with a telescope is modifying. Under one meaning, with a telescope is modifying the Martian. In this case, we don't know anything about the seeing. Under the other meaning, Ingrid has the telescope, and now with a telescope is modifying saw. How did Ingrid see the Martian? With a telescope. Which Martian did she see? We haven't said anything about this. Arrows like this are great, but they're kind of imprecise. Is the arrow pointing to the? Is it pointing to Martian? Or is it pointing to both of them? With just an arrow, we don't really know. Instead, we use what linguists call a tree structure diagram. You might recognize it from this video. Let's start with a basic example. Here's our sentence. What can we figure out about it? One thing you might notice is that if we swap Ingrid and the Martian, we get a different sentence, but it's still perfectly good. That wouldn't be the case if we swapped Ingrid and saw, and it wouldn't even be true if we swapped Ingrid and Martian, leaving the behind. So there's something really special about Ingrid and the Martian. They're sort of the same thing. We call them NPs for noun phrases. They both have nouns in them, but they can also have other things like the determiner the. If we're talking about NPs, then what about the verb? Just like the noun has a noun phrase, the verb has a verb phrase. And we also have an S, that stands for sentence. Now, what do we do with the with a telescope part? Since with is a preposition, we'll give it a prepositional phrase. And since I'm not worried about the internal structure of the PP for the moment, I'm going to use this triangle to indicate the whole phrase at once. Let's start with what happens if the Martian has the telescope. Since the whole thing, the Martian with a telescope, is what Ingrid saw, with a telescope has to be part of the Martian's noun phrase. Now what happens if the telescope part is associated with seeing? Who did Ingrid see? The Martian. How did Ingrid see? With a telescope. Now the prepositional phrase is up here. You can read the linear order of the sentence off the tree by reading along the bottom. Ingrid saw the Martian with a telescope. But notice when we do this, it doesn't matter where the prepositional phrase attaches. Whether it's up here at the VP level or down here with the NP, it's still going to give us the linear order that puts the prepositional phrase right at the very end. Linguists call this phenomenon attachment ambiguity, since the confusion arises from the fact that the linear order isn't giving the listener clear information about where the PP attaches. So what? Is this just a weird property of sentences with the word telescope in them? Probably not. Let's try it with a whole nother set of words. What about the sentence, I wrote the letters on the kitchen table? This sentence is also ambiguous. Under one reading, the letters are currently on the kitchen table, and I wrote them. Under the other reading, the kitchen table goes up here with the VP, and in this configuration, the letters were written at the kitchen table, but they could be anywhere right now. Here are some more sentences that are ambiguous. You should think about them. Edna hit a Yeti with the frying pan. I bought this unicycle for my best friend. Nigel remembered the concert after the rainstorm. It's good practice to sit down and think about the different possible readings that each linear order could have. Bonus! Here are two more ambiguous sentences that have slightly different attachment ambiguity. I will eat the pie that you will bake tomorrow, and one-eyed, one-horned, flying purple people eater.
What's up, everyone? This is Education About Stuff. I'm going to be showing the CYK algorithm today. And what the CYK algorithm is whenever you have a string W, let's say, and this is your string W, it looks at what kind of derivations you can obtain while referencing a grammar that we have here. 4 different substrings of that larger string. So we look at derivations of just B, look at derivations of just A, and so on, and then we look at BA, and then BAA, BAAB, and then BAABA at the end. Okay, so let's get started. It's pretty basic to start out. It's very intuitive, but it gets a little tricky. So first off, we look at the letter. So if we look at the letter B, B is a terminal value in our grammar here for the state B, for the label B, and only B. So we look at the letter in the string, and we say, where can we obtain B? And we can only obtain B in state capital B. So we put capital B in here. Where can we obtain A? We can obtain A in state capital A and state capital C. So we write in A and C, and then it's just A and C again here. It's just B again here, and then A and C again here. So now this is when things get a little trickier. Let's take out these arrows here. This is when things get a little trickier. By the way, sorry about my voice. I got a bit of a head cold right now. Instead of looking at the actual string, we want to start looking at substrings. So we're going to be looking at B and A first, which is why our graph here was our table was reduced by a square. It's because we're going to be looking at combinations of 2 letters in our string now. So if we take a look here, we're going to be looking at string BA. So when we look at how B and A are produced, we can take the the Cartesian product essentially of these 2 production rules. So we end up with BA and BC. So let me look in our grammar again. Where do we obtain BA? We obtain BA in state capital A. Where do we obtain BC? We only obtain it in state S. So we write SA up here. Now, oops, this is a new version of OneNote that I'm really not used to yet. Sorry, guys. Now we look at A and A. So we do the Cartesian product of A and C and A and C, so we end up with A, we end up with A, C, we end up with C, A, we end up with C, C. So where do we get AA? We don't get AA. Where do we get AC? We don't. Where do we get CA? We don't. Where do we get CC? We get it in B. So we'll put B up here. Okay. So now we're going to be looking at AB. So we have A and C, and we have B for those 2 letters. Do the Cartesian product, so we have AB, and then we have CB. So where do we obtain AB? We obtain it in both S and C. Where do we obtain CB? We don't. So this is SC. And then finally, we're going to do BA at the end here. So we have B, we have AC, we take the Cartesian product, so with BA, we end up with BC. Where do we get BA? We get it in state capital A. Where do we get BC? We get it in S. So we'll do SA here. Okay, so things get a little harder here. Basically, we're going to be looking at 3 letters at a time now. So we're going to be looking at BAA. Now, because we have 3 letters, we have different combinations of substrings. So we have B, and then we have AA, we have BA, and then A. So those are just different combinations, the 2 different combinations of substrings that we can have for that beginning string there of 3 letters. So let's take a look. We have B here, which is taken care of by state capital B. So we have B, and then we have double A. We already took care of double A here. Remember when we were doing 2 letters at a time. So we already took care of double A there, and that is also B. Then we have BA and then A. So we already took care of BA again. It's SA, which is here. So again, when we took care of 2 letters, we did BA. We did it in this cell here. So we have SA, and then when we did just 1 letter at a time, we did A. So that's AC. Now we take the Cartesian product of what we obtained from each substring. So here we end up with just BB, and here we end up with S and A from that, and then we end up with S and C, and then A and A, and then A and C. Now this is interesting because none of these are in our grammar. We can't obtain any of these in our grammar. So when that happens, we just put a little dash in there. Okay, so next we'll take AAB. So our different substrings are A and then AB, or AA and then B. So we already did A, which is here. It's just AC. So we have AC, and then AB we already did as well. That's SC. And then here AA we already did that. Ends up with B. And then just B we already did as well. Ends up with just B. So Cartesian product here again is just BB. And then here it's AS, AC, then CS, then CC. So just taking a look at this again, we only have CC once, and that's on state capital B, as you can see here. So we just put, oops, that's not black. We just put capital B here. So just to go over that again, we have CC only once in our grammar, and this is the Cartesian product of a couple production rules from our substring AAB. So since this is the only result that we have, we put it here. Okay, now our last substring ABA, so we can have A or BA or AB or A, and we end up with AC and BA is SA, and then AB is SC, and A is AC. So if we do the Cartesian product, we end up with AS, AA, CS, CA, and SA, SC, CA, CC. So it looks like CC is our only one again, which is present in state capital B, which means that we put a capital B. Okay, so now it's getting to my least favorite part, where we start doing 4 letters. So our substrings are BAAB, BAAB, BAA, B. So B is just B, and then AAB we already did. That's B. BA we already did. That's SA. And then AB we already did. That's SC. BAA we already did. That's nothing. Then B is B, so this one is canceled out because we have nothing here. So we don't have to do that one. So here we end up with just BB as our Cartesian product. Here we end up with SS, we end up with SC, we end up with AS, and we end up with AC. So again, none of these are in our grammar, so we just put a dash. Okay, so now we're going to look at AABA. So we have A, BA, we have A, BA, we have A, B, A. Alright, so A is just, sorry, I'm kind of changing colors a lot here, not really keeping track. ABA is B, AA is B, and BA is SA. So I know I'm going kind of quick here, but just to show you again, for like string AA, we already did it. It's this string here, and we did it in the second row, so that's just B. And then SA is for the substring BA, which is this one here, which we already did as well. It's in row 2 here. So that's just where I'm getting those values from. Okay, AAB is B, A is AC, so now we do the Cartesian product. So we have AB here, we have CB, we have BS, BA, BA, BC. So here AB, we have AB in state S, we have AB in state C. CB we don't have, BS we don't have, BA we have in state A, BA we have in state A, and BC we have in state S. So because we have repeated states here, we only have to say them once. So we just do S, A, C. Because we have S and C here, we have an A here, we have an S, like a repeated S here, we have a repeated A here. We don't need to include these twice, we just do SCA, or SAC, whatever. I like doing this order just because it's the order in which the grammar lists the states. So, S, A, C. Alright, so I'm going to write out the substrings and just prep the last step here. I'll cut out for a sec. Okay, so here we have 2 blanks. So we have BAA, which is this one here, and then we have BAAB, which is this one here. So these 2 we don't have to do. So these are just done. We forget about those. Alright, so we have for our Cartesian products, we have BS, we have BA, we have BC. For this one we have SB and AB. Okay, so BS, we don't have BS. BA is in state capital A. BC is in state capital S. SB we don't have. AB is in states capital S and capital C. So again, we have a repeated S, so it's just SAC again, because SAC. Okay, so that's it.